Okay, if you look in the standard assets, port package, scripts, there's a mouse orbit script here which is very similar to what we're going to be trying doing. Let's just even import that, talk about it quickly. Okay, standard assets, scripts, mouse, orbit. Okay, we're going to try and get these rotations moving around so that we can move the mouse and we can rotate around the current position. But we're going to do it in the local position so that when we set up the camera like we have, it's not going to be resetting the angles. So this is going to be looking at trying and storing Euler angles, recalculating a rotation, and then feeding all those Euler angles back in. Okay, so let's create a script for that. So this is going to be our menu, menu, mouse, look, script. Okay. Where is it? Okay, so yeah, we're not going to be orbiting around something, we're just going to be changing our local rotation as we look around. And then we're going to raycast from the center of the screen to select an item. So we do need a speed, we do need a min limits, and then we need to store our rotational variables. Okay, so our x speed, we type float, and let's just set it to 2 at the moment. Same here for our y speed. Okay, and we're going to have an x min limit. We're going to have an x max limit. And then the same for the y. A y min limit. We're going to have a y max limit. Okay, and then we're going to need our private variables, which will be storing our rotation x, rotation y, and our rotation z. Okay, and these are what we're going to be feeding back into the camera when we set the angle. Okay, so to start off, and let's cache the transform, yes of course. Okay, my transform. What's the camera transform? So let's just call it camera transform, which is a type transform. Okay, let's store that first. Camera transform equals transform, and our rotation x will equal camera transform rotation dot Euler angles dot x. And you can see we're going to do the same for all of them. Make sure you get your x, y's, and z's correct. Okay, y, z, z. Okay. So we store the current rotations of the camera. Now every update we're going to check for a mouse input, and then we're going to modify that stored rotation, and then we're going to set the camera's rotation to that stored rotation. So basically we always know our rotation in Euler angles that we want, and we keep feeding that to the camera through a quaternion, a rotation that works. So instead of trying to read the current rotation and manipulating it, we're going to be doing this. Okay. So every update, how do they do it with input get axis? Well, normally I'd store the last position of the mouse, the input mouse position, and I would store the current one, and it would find a delta, a change in the magnitude between the two. But if we can just do axis on the mouse X, we'll just do input get axis. So, if we're moving the mouse left and right, we're moving it on the X. But on the camera, that would be rotating on the Y-axis. So, rotation Y, add to it, mouse X times X, so we're using the X speed, times, so yeah, you put time delta time, which would be 0.16 or something, and they just used 0.02, so that was very clever, wasn't it? So let's just do that. Okay, this is where it gets confusing. So this is for horizontal mouse movement, rotate on camera Y-axis. And this is going to be for vertical mouse movement, rotate camera on the X-axis. So we have to make sure we get these right. Rotation on the X-axis is equal to the mouse Y, the vertical. And I think that might be inverted, that might be minus. Make sure we get the Y speed in first. We'll be able to test that soon enough. Okay, so we're modifying the X and the Y rotations which we've stored based on an input. Now, we're working in rotations, Euler angles, that's what we're trying to store. A number between minus 360 and positive 360. So we want to clamp this value to that 360 value. So, function clamp rotation. Can't call it clamp angle because they've created a static variable, a function clamp angle. So I can't use that. So we're going to feed it rotation, and we're going to feed it the minimum rotation, we're going to feed it the maximum rotation. And yes, I do have to declare all these as floats. Okay, so we've added or subtracted to our rotations. So we're going to have to clamp rotation after that. So let's do the Y first. Rotation Y equals, I'm going to clamp the rotation. Between what? I'm going to clamp it between what we calculated, and if we're working in the Y, we're going to use the Y min, we're going to use the Y max. Okay, and same for rotation X. I'm going to clamp rotation of the calculated rotation X between the X minimum limit and the X maximum limit. So what happens in clamp rotation to clamp those values? So if and then there's, let's just copy that out. There's a couple of things we have to check. We have to check if it's less than minus 360 or greater than positive 360. So if rotation is less than minus 360, it's a float, yeah. We can make this an else. Else if rotation is greater than positive 360. What are we going to do there? Rotation, I'm going to add to it 360 And if it's greater than 360, we're going to subtract from itself 360 to bring it back towards the 0. Okay, then we have a final value. Between minus 360 and 360, yep. So the rotate equals mapf dot clamp pretty much everything here. Rotation and the minimum and the maximum rotation. Get that? Yep. Now we want to return that variable because we said this rotation equals the result of that clamp rotation. So we're returning a float. So we have to declare it here in the function. So let's say float. We're going to be sending back a float value. And then we say return. This whole function is just like doing an equation. We said, okay, our rotation equals whatever this function, this equation does, what this function returns. Going, okay, we've got some numbers, let's do some calculations and let's return a float. He goes, okay, there's your float, give it to the variable. This is what's happening right here. So we return the rotation. Okay, so let's just see if there's any compilation errors, because there's a lot of typing there. And happily for me, there's no compilation errors.